Hello students, welcome to class ninth. That is last class. We were seeing the change of states by applying temperature, latent heat of vaporization, then latent heat of fusion. So we have seen all those cases, and even we have seen deposition, sublimation, okay. So condensation, solidification, we have seen all across those, all the six processes of conversion of change of state by applying temperature. Whether by applying temperature or whether by applying pressure, the processes are called by the same name. But last class we have seen by applying temperature how we have to change the state of a matter. Okay, if you increase the temperature of water, it will become vaporize, that is vaporization. If you increase the temperature for ice, if you increase temperature it becomes liquid, that we call as melting or fusion. Okay, there we have seen latent heat of fusion, and after that latent heat of vaporization and sublimation. We have seen example of sublimation is camphor, okay, naphthalene balls. So we have seen all this solidification, we have seen then condensation, we have seen. So these are all the deposition we have seen. So these are all things we have seen in the last class. So today we'll see how effect of pressure will change. Effect of pressure, effect of pressure will change the states of matter. Suppose if I take some molecules here, okay, and if I apply the pressure here with some distance, say, okay, I will write. So I think, can it be visible? Yeah, it's another color. Okay, okay. I will apply the pressure here. What will happen if I apply the pressure? So these molecules will come together, come little bit closer, isn't it? Okay. If I apply more pressure, then what will happen? So all will come very closer. They become small and very closer. Okay. So by applying the pressure, the molecules or the particles, we can say, the particles will come very closer. So when the particles come closer, what will happen? The state changes. Suppose if I say this is gaseous state, if you apply the pressure, it will convert to liquid state. If you apply further pressure, it will convert it to solid state. As you have already known, gaseous state is the particle separation or interparticle distance is more. In liquid state, it is moderate or medium. When it comes to solid state, it is compact. It is highly more. Okay. So this is how effect of pressure happens. If you increase the pressure, gas will convert to liquid, liquid will convert to solid. See, if you have come across the word CO2, CO2, solid CO2 we can call. From CO2 which is in gaseous state, it can directly convert into solid state by decreasing its pressure to 1 atmosphere. So directly it will convert it to solid state. Directly it will convert it to a solid state when you maintain its pressure to 1 atmosphere. If you maintain the CO2 to 1 atmosphere pressure, it will become solid ice. It will become what? Solid state. So that is why CO2 is called by the name solid ice. The question might be asked, why CO2 is called solid ice. when CO2 is maintained at 1 atmosphere, when CO2 is converted from its present pressure to 1 atmospheric pressure, then it converts from gaseous state to solid state. So that is why CO2 is also called as solid ice. I hope you all are clear with this point. Why CO2 is called as solid ice? CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere. When there is a decrease of pressure to 1 atmosphere, then CO2, which is a gas under high pressure, will convert directly to solid. Okay, hence it is also called as solid ice. So we have to remember these things. Okay. Okay. So now we'll move further. So this one you understood, CO2 gas and all these things you understood. Okay, we'll move further. So we'll see the conversion. Conversion, we'll see conversion, conversion from degree Celsius to Kelvin or Kelvin to degree Celsius and Kelvin to degree Celsius. What is conversion? Conversion of temperature. This is conversion of temperature. Temperature you already know. Just I need to convert the temperature. So I will give you an example. So let me say conversion from degree Celsius to Kelvin. First we will convert degree Celsius to Kelvin. Convert 35 degree Celsius and 0 degree Celsius to Kelvin. So see, Kelvin is equal to, because you want temperature in Kelvin, that is K is equal to what is given in degree Celsius plus 273 is the formula. K is equal to degree Celsius plus 273. That is temperature in K, or you can say TK. Temperature in K. That is temperature in Kelvin or KT you can say. So TK is equal to what is given in degree Celsius? 35. It is given plus 273. So what is my answer? 5 plus 3 8. Then 7 plus 3 10. 1 will come to 1. 308 Kelvin. The temperature required in Kelvin is 308 Kelvin. Okay. Next 0 degree Celsius, here I will make TK is equal to C degree Celsius plus 273. Okay. TK is equal to or K is equal to, you can write. You can write in whichever way you want. Either you write TK or K. Whichever you feel good, you write. In degree Celsius, it is given 0. 0 plus 273 is 273. So K or 2K is equal to 273 Kelvin. Or you can say this as TC, T in degree Celsius. You can say TC, TK is equal to TC plus 273, T in degree Celsius. That is temperature in degree Celsius. You can remember like this. K or TK is equal to 273 Kelvin. Okay, I hope you all are clear with this. Just very easy formula. So if it is given in degree Celsius, to convert it into Kelvin, just add 273. If I have to add 273, if you want to convert it to 2 Kelvin, ನಿಮಗೆ ಕೆಲ್ವಿನ್ ದಾಗ ಬೇಕಾಗಿತ್ತಂದ್ರೆ 273 ಆಡ್ ಮಾಡಬೇಕು ಪ್ಲಸ್ 273 ಮಾಡಬೇಕು. ನಿಮಗೆ ಕೆಲ್ವಿನ್ ದಲ್ಲಿ ಬೇಕಾಗಿದ್ರೆ ಪ್ಲಸ್ 273 ಮಾಡಬೇಕು. ಇಲ್ಲ ನಿಮಗೆ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಬೇಕಾಗಿದ್ರೆ ಮೈನಸ್ 273 ಮಾಡಬೇಕು. So Kelvin is the big one. Kelvin should be always more number. So if you want it in Kelvin, just add 273 to it. If you want it in degree Celsius, just subtract 273 from it. Okay. So now we'll see another two problem which will be converting. We are converting from degree Celsius to Kelvin. We have seen. Now Kelvin to degree Celsius. If I write convert what we can say 373 Kelvin and 298 Kelvin to degree Celsius. So temperature in degree Celsius, we'll write it as Tc. Okay, I can write it as Tc, temperature in degree Celsius. That is what is my formula. I have to subtract 273. That is temperature in Kelvin minus 270. What is temperature in Kelvin for me? Tc, temperature in Kelvin is 373 minus 273. 373 minus 273, 100 degree Celsius. Tc is equal to 100 degree Celsius. While writing degree Celsius, it must be compulsory to write degree. For Kelvin, it is not needed. You are no need to write. Sometimes they write radian here. It is not needed for Kelvin. Even though you can write it normally, but for degree Celsius, you have to write this compulsory. Okay. You have already heard about this regarding temperature. If you are watching TV, they tell in Bangalore today there is 28 degrees Celsius. In hot conditions, they will tell in Vijaypura, in Mudod, in Bagalkot, there was 38 degrees Celsius recorded today. Okay. In phone, if you see, there is 24 degrees Celsius, 25 degrees Celsius, 28 degrees Celsius. You can see all those things there. Okay. If in my phone, I will show you if it is there. I think it is not there. Degree temperature. Okay, it is not there. So it is there if you are able to see here. So I think in your phone also there cloudy 24 degrees Celsius is there. I think you can't able to see that. Okay, let it be. So in your phone also there if it is maintained, here it is cloudy 24 degrees Celsius. So now it is 24 degrees Celsius. So that is temperature. If you convert 24 degrees Celsius to Kelvin, what it will become? 24 plus 273. How much it will become? 297. 297 Kelvin. Now converting 298 K to 0 degree Celsius. 298 K to 0 degree Celsius. So I want temperature in degree Celsius. I will write Tc. So what is my formula? Tk minus 273. My Tk is given as 298 minus 273. That I will write as 25 degrees Celsius. Temperature in Celsius. Degree Celsius is 25 degree Celsius. Even I can write it as T temperature in degree Celsius or temperature in degree Celsius. Or you can write it for your convenience. Tc is enough. Temperature in degree Celsius. So these problems are given in your textbook. So please open your textbook, page number 9. So please all of you open your textbook and page number 9. So don't simply sit, open your textbook of page number 9. So there are some questions I am going to discuss those questions. So page number 9, okay, starts only with questions. Those questions I am going to discuss which are in blue color. So the first question is there, convert the following temperature to Celsius scale. You can easily convert them. So what is first one? 300 K. If you convert it into Celsius scale, in the same way, 300 K means you have to minus it into 273. 300 minus 273, you will get that as 27 degrees Celsius. Okay, second one 573 K. Again same 573 minus 273. Take the formula Tc equal to Tk minus 273. Tk is 500. So 500 minus 273. 573. 573 minus 273. You will get 300 as the answer. So second question is there. What is the physical state of water at 250 degrees Celsius and 100 degrees Celsius? See, what is the physical state of water at 250 degrees Celsius and 100 degrees Celsius? See, what happens in 0 degrees Celsius, water is in the form of ice. We can say solid. 0 to 100 degrees Celsius, it is in the form of liquid. So we call it as water. From above 100 degrees Celsius, 100 plus to any number, it is in form of steam. Steam, or we can say evaporated, vaporized water. Okay, that is gas. So what they have asked the first one, 250 degrees Celsius. 250 degrees Celsius means what it is? It is in gaseous state. It is in gaseous state. At 100 degrees Celsius, it is in liquid state still. But sometimes it is converted to, some part is getting converted to boiling. That is getting converted to gas. That means you have to say it is in equilibrium state, you can say, or you can say it is in liquid state. But for 250 degrees Celsius, it is fixed. It is in gaseous state. Okay, third one. For any substance, why does the temperature remain constant during the change of state? ಯಾವುದೋ ಸಬ್ಸ್ಟೆನ್ಸ್ಗೆ ಡ್ಯೂರಿಂಗ್ ದ ಚೇಂಜ್ ಆಫ್ ಸ್ಟೇಟ್ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಯಾಕೆ ಉಳಿತದೆ? Because whatever the temperature or whatever the heat energy we are giving, that is all used to change the conversion of state. Not, there is no increase in temperature. Suppose for what is happening for ice is there. Ice is getting converted to water at 0 degrees Celsius. Okay, below 0 degrees Celsius it is ice. From 0 to 100 it is water. Okay, so it converts to water. Whatever the heat you are giving used to melt the ice, conversion of state is there. So that is as latent heat of fusion and latent heat of vaporization. Due to latent heat, or you can say whenever the heat energy is given, that will be used for the conversion of state. Hence, during the conversion of state, the temperature remains constant. I hope you all are clear with the concept. And last question, suggest a method to liquefy atmospheric gases. You find out this. Okay, I am giving this question to you. If you are not answered, I will answer in the next session. No need to worry. So you have to be perfect. And there are some exercise questions also there. First two questions of exercise you start solving. You know how to solve Kelvin and degree Celsius. So start solving the exercise, leaving some pages, 2 to 3 pages you leave for the next 1 or 2 class. Okay, 2 to 3 pages you leave for making the notes, and you start solving the exercise. Okay, so this is regarding conversion of states. I hope you all are perfect with this. Okay, or shall we solve those two problems also? So I am going to solve one problem, that is 300K and 250 degrees Celsius. Or shall we move for the next concept? Okay, we'll move for the next concept. It is easy, you know already TC and TK, you know already. So I think we'll move to evaporation. What happens with evaporation? We'll move to the next concept. Only we learn what is evaporation in this class. Factors affecting evaporation we'll learn in the next class. So what is evaporation? See, evaporation and vaporization both are different phenomena. In evaporation what happens? There is a large amount of water or liquid, you can say. They gain the molecules of, or the particles of that liquid, they gain some energy to come out of the intermolecular or interparticle force of attraction. They come out of intermolecular or interparticle force of attraction. When they come out, so they will get into the vaporized form. They will get evaporated. Suppose if I say So after washing your clothes, so what you will do, you keep them outside, you hang them outside, so the wet cloths will become dry. How it happens? It happens because of the process called evaporation. So evaporation is a surface phenomenon. It happens only at the surface level. Here also, if you take water here and if you kept it outside, okay, if you take the water and if you kept it outside for hot, if you kept it outside for the hot, okay, heat, then what will happen if the temperature is more? If you kept, suppose if you kept it in the afternoon, okay, so this surface, the water at this surface gains, the particles of the water at that surface gains some energy to come out of the interparticle force of attraction, and they will become evaporated. So this process is called as evaporation. This is a surface phenomenon. What it is? It is a surface phenomenon. Particles from the surface gets some energy. Evaporation is a surface phenomenon in which particles from the surface gets energy to come out of the interparticle force of attraction, and they get evaporated. This process is called as, or they get vaporized, or they get into gaseous state. So this process is called as evaporation. So I will tell you once again what is evaporation. Is the surface phenomenon in which particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. So you can say, what you can say? Evaporation, the process in which evaporation, or you can start define evaporation, the process in which the particles gain some energy to come out the force of attraction between the liquid and they get into the vaporized state. So evaporation is the process in which the particles of the liquid gain some energy to overcome the force of attraction of liquid and they get into vapor state. So this is called evaporation. So we have to write the definition and you have to understand. Evaporation and vaporization both are different. In vaporization what happens? We are giving heat. After 100 degrees Celsius vaporization will happen. If you boil the water, you will get the steam. Okay, that is vaporization. After 100 degrees Celsius water is getting converted to what? Gaseous state. So that is vaporization. But here it is happening below 100 degrees Celsius, below boiling point. Even though the water is at 25 degrees Celsius, 28 degrees Celsius, still some part of water will vaporize, will get into vapor state. So this is evaporation. And evaporation is a surface phenomenon. Vaporization is a bulk phenomenon. It is not a surface phenomenon. In vaporization what happens? Bulk number of molecules, means large number of particles gets vaporized suddenly, but here not large number of particles, small particles, small amount of particles starts evaporating. Okay, so this thing you should remember. Vaporization is different, evaporation is different. Vaporization means you have to heat after 100 degrees Celsius, they get converted to gaseous state, that is vaporization. In evaporation there is no need. It will not cross 100 degrees Celsius, below 100 degrees Celsius only, below its boiling point only. The particles will come out of the forces of attraction of liquid and they will become vaporized. So this process is evaporation below its boiling point. That is very, very important. It is a surface phenomenon. The surface phenomenon in which The particles of liquid gain some energy to come out of the forces of attraction of liquid and they gets vaporized. This process is called as they gets vaporized below its boiling point. Below its boiling point. So this process is called as evaporation. Evaporation happens below its boiling point. Vaporization happens at its boiling point. Evaporation is a surface phenomenon. Well, vaporization is a bulk phenomenon. Or you can say evaporation is vaporization is a complete phenomenon. It goes inside also. Okay, so you should remember these two things. What is difference between evaporation and vaporization? Okay, so in factors affecting evaporation, we will see that all in the next class.